Hello and welcome to section 2.6b, writing equations of parallel and perpendicular lines. So we've already talked a little bit about parallel and perpendicular lines and what their slopes mean. And we said before that if two lines are parallel, they have the same slope. And if two lines are perpendicular, they have slopes that when you multiply them, you get a product of -1. Or you can refer to that as their slopes are opposite reciprocals of one another. So you can use your slope-intercept form or the point-slope form to write equations of parallel and perpendicular lines. And like I just said, parallel lines have the same slope. So I asked you to list some lines that would be parallel to y equals -3x plus 1. In this section, you can basically list any line that has the same exact slope. So I can say y equals -3x. I could say y equals -3x plus 100. I could say anything I want except for y equals -3x plus 1 because those wouldn't be parallel. They would be right up on top of one another and all their points would cross. So that's not parallel. All right, so how do we write equations of lines that are parallel and pass through particular points? Here we go. Step 1, you look at the equation, identify what the slope is. Then we're going to plug the slope in for m and the point that's given in for x1 and y1. And solve the equation for y. So basically, I'm going to give you an equation, and I want an equation that is parallel to it that passes through a certain point. And I have two examples to go along with that. So the first example says, write an equation of a line that passes through 6, -2 and is parallel to y equals 1/2 x plus 3. Okay, so if I want an equation that's parallel, the slope has to be the same, right? The slope in this equation is 1/2. So right now, you have the slope and the point for an equation that you want. When you're given a slope and a point, plug it into point-slope form. So y, and it's supposed to be minus y1, right? You're going to subtract a -2. That means y plus 2 should be equal to m times x minus x1, and it's a 6, so I'm going to leave it as subtraction. Okay, I want my equation in y equals mx plus b form. So we're going to do what we did a couple days ago. I'm going to distribute. 1/2 times x is 1/2 x. And 1/2 times -6 is -3. Now I want this 2 to go away, so I'm going to add the opposite of it. And I get y equals 1/2 x. And you can write plus -5, or you can write -5. Both are the same. So basically, this equation right here, y equals 1/2 x plus 3, this equation here is parallel to that and passes through the point 6, -2. Let's try one more of those. Okay, I ask you to write an equation that passes through the point 1, 2 and is parallel to y equals 5 minus 3x. So we have a point, and we're given the slope in this equation. Please be careful, the slope is not 3. The slope is -3. The coefficient of x is technically -3 because we're subtracting it. So m is -3. The point that you're given is 1, 2. So let's plug it into the point slope. Y minus y1 equals the slope times x minus x1. Step 1. Step 2, let's get rid of those parentheses. So I have -3x, and this is going to be plus 3. When you take this -3, you're multiplying it by a -1 because you were subtracting 1. And if you keep making errors with that, that's when I recommend to keep change. That's why I always show you both ways. Now I want this 2 to go away. It's a -2 because it was being subtracted. So I'm going to add a +2 to cancel it out. And y would equal -3x plus 5. So those two equations are parallel and pass through the points 1, 2. And do you notice? It's kind of crazy. They're the same point. I just took an example from before, so I know this is a weird one, but it's the whole process. So hopefully we have the process down. Take the slope from the original equation, plug in the x1, y1, rearrange it into y equals mx plus b. Perpendicular is kind of a different story. Not too much of a different story, though. The whole process is pretty much the same, but when you're dealing with the slope, you don't take the original slope. You take the slope of one that's perpendicular. which is what I call opposite reciprocal. So perpendicular slopes, or perpendicular lines, have slopes that are opposite reciprocals of one another. The lines intersect to form 90-degree angles. So, first of all, let's just identify the slopes in these equations. When you look at the first equation, y equals negative 3x plus 1, the slope is the coefficient of x, which is negative 3. The slope in this equation would be a positive 2/3. The slope in this equation would be 5. Perpendicular slopes are the opposite reciprocals. And by opposite, I mean if your original slope is negative, then the perpendicular slope needs to be positive. And if your original slope is positive, then the perpendicular slope needs to be negative. That needs to happen because a negative times a positive is a negative. And remember, we need to get a product of -1 for their slopes to be perpendicular. So, the reciprocal of -3, this is really 3/1, right? So the reciprocal of that would be 1/3. Opposite reciprocal means this was negative, so it's going to be positive. So the perpendicular slope of -3 is 1/3. If you want to write opposite reciprocal, maybe abbreviate. Opposite reciprocal, that's what you're looking for. Okay, this is 2/3. The reciprocal of 2/3 is 3/2. The opposite of the positive 2/3 would be negative. So -3/2 would be the opposite reciprocal of 2/3. This slope is 5, which is really 5/1. So the reciprocal of that would be 1/5. This was positive, so this would be negative. So basically we're going to do what we did before with parallel, except when we identify our slope, we're going to take the opposite reciprocal of that when we plug it in to the point slope formula. All right, so turn the page. Here we go. Let me make sure you can see. Here are your steps listed out nice for you. Identify the slope, take the opposite reciprocal of it, plug the opposite reciprocal of the slope in for m, and a point given in for x1 and y1, and step 3, solve the equation for y. Same kind of concept as what we did before. So your job right now is to write an equation of the line that passes through this point and is perpendicular to that. So first off, the original slope is 1/2, right? To find the perpendicular slope, I need the opposite reciprocal of that. So the slope I want, let's first take the opposite sign. It was a positive 1/2, so now I need negative, right? The reciprocal of 1/2 would be 2/1, correct? And 2/1, that's really 2. So the slope I want to use is -2, because that's the opposite reciprocal of the slope given. So plug it in. I'm going to take y minus y1. Now y1 is a -1. When you subtract a -1, that means you're adding. It's the same thing. That equals the slope multiplied by the quantity of x minus x1. Now that's already a positive 1, so I can go ahead and write -1. Now back to the basics. Let's get rid of those parentheses. So I have a -2x, and be careful here. I should be writing +2, not -2. I need to get rid of that -1 now. I'm sorry, that positive 1 by adding a -1. So y is equal to -2x, and 2 plus -1 is 1. And this would be perpendicular to one another and pass through the point 1, -1. Let's try one more, because usually one example isn't quite enough, I have found. Write an equation of the line that passes through this point and is perpendicular to y equals -2x plus 5. Well, first off, for my slope, it needs to be opposite. So this one was negative, my new one's going to be positive. And the reciprocal of 2/1 is 1/2. So now I'm looking for an equation that has a slope of positive 1/2 and passes through -3/7. Don't do that, buddy. Sorry, my son is hanging out with me this morning as I'm doing these notes, as you have probably found from the other things. I'm recording all of Unit 2 today. Do you want to say hi?
Hi.
That's my Ethan. All right, so y minus y1, it's a positive 7, so I'm going to leave that as subtraction, is equal to the slope that I want, which is 1/2, times the quantity of x. And it's supposed to be minus x1. That's a -3. So when I subtract a -3, that's really +3, right? Okay, so let's get rid of some parentheses first. Y minus 7 equals, well, 1/2 times x is 1/2 x. And when you take 1/2 times 3, yes, that's 3/2, or 1.5 if you want to write it that way. I'm going to leave it as 3/2 for now. Why not? Now we need to add 7, add 7. So y equals 1/2 x plus, when you take 3/2 plus 7, remember 3/2 is equal to 1.5. When you take 1.5 plus 7, yes, it is 8.5, or 8.5. And that's my equation. Voila. Right, one last problem here, because sometimes I'm not going to give you in words, I'll actually give you a graph. This says, write an equation of the line that passes through -3, 1 and is perpendicular to the line shown on the graph below. So I give you a graph, I give you a point, I didn't give you the slope though. And in all these, haven't we been using the slope in one point? We have. Do you know how to find the slope of a graph? You better say yes. You do. Let's do rise over run. So one point to the next, I'll go up 1, 2, 3, 4, and I'll go left 1. So that makes this slope 4 over -1, or -4, right? So that's the slope of this graph. Now, I want an equation that's perpendicular to that. Remember, perpendicular means opposite reciprocal. Well, this was a -4, right? So this means I want my slope to be the opposite. So opposite sign would mean positive. And this was over 1. I just need to flip it. So the slope of an equation that's perpendicular to this would be a positive 1/4. Opposite reciprocal of the original slope. I want it to pass through the point, we said -3, 1. So now I have my slope and my point. So we're going to take y minus y1, set that equal to the slope that I want, multiplied by x, and it's minus x1. So when you take minus -3, you're going to add a positive 3. So y minus 1, let's distribute. I have 1/4 x plus, when you take 1/4 times 3, yes, it is 3/4. It's okay, fractions are our friends. Let me scooch that up so you can see it, that would be nice. I'm going to add 1 to each side. So y equals 1/4 x plus 3/4 plus 1. Yes, that's 1 3/4. If you wanted to write y equals 0.25x plus 1.75, you could. I don't mind you leaving them as fractions though. There's nothing wrong with a good old fraction. We're done. I'll see you tomorrow. Bye.